Hi and welcome to today's meeting for Here's a Gizmo, and today we're going to be looking at the MCP23017, which is an I2C GPIO expander, and we're going to be this is going to be part 1, basics of information. And here you can see what we're hoping to show you we can achieve using one of these devices connected to an ESP32. So this device here is made by Waveshare. It's quite cheap, it's not too expensive. I used these originally a few years ago on a Raspberry Pi project. Now the nice thing with these modules is they are 3.3 volt compatible as well as 5 volt compatible. Now being I2C, they come with a default address of 0x27. Now this can be changed by altering these tabs here. Then it will give you the option of 8 different addresses from 0x20 to 0x27, as I say. Now the thing is, this is very similar to the PCF 8757 that Steve showed the other week. It gives us 16 digital inputs which can have internal pull-ups, resistors, or outputs, and they can all be individually selected. It does allow for interrupts. It has 2 different types of interrupt pins, one for bank 0 or A and bank B. So this will work with various MCUs, and one of the reasons why I'm showing it today is you're going to see this eventually coming into play with the LCC nodes that we're going to be showing. It requires a ground and VCC, so we've got the 2 leads here, the red and the black, and you then have 2 pins which are required, which are SCL and SDA, so the yellow and the blue wire, and then the green and the red wire, which are the 2 different interrupt banks. Also over here you can add extra breakouts to allow it to be daisy chained to different the next modules. There is one limiting factor, which is the limited number of ground pins. So here you can see it connected to an ESP32, and in this case I'm supplying it with 3.3 volts using this jumper here, and then I've connected it to pin at the SDA to pin 21, SCL to pin 22. Now you need to make sure you use suitable current limiting resistors to protect the pins. This module is capable of driving LEDs. Now here you can see it's rather bright. This one here has not got a current limiting resistor, not a good practice. Now in this case we're driving the LED on pin 0 or A0. Now we'll just take a look on this one. This sketch here, I'm using the Arduino IDE, and we're using the Adafruit MCP23017.h library. Now this code here is one that has been set up to work with the ESP32. So here you can see we've called in the libraries, which is the wire library and also the Adafruit library. Now I'm going to take you into the Arduino IDE now. So the first thing we need to do is go to the library manager, and if we type in here MCP23017, you'll see we've got 2 different libraries. The one we're going to be using is the Adafruit one here. So you would, obviously I've already got it installed. You would not have it, so you'd click on install and it would download, and then once you've got it downloaded you can go to here, file, examples, scroll down, and as we get down to here you'll see we've got a number of examples that they show. Now there is a slight issue, so we're going to take a little look at the blink example. I'll just close this down here. So here you can see the example that they give you. Now, obviously, The Adafruit make two versions. One is using SPI and one is using the I2C. So you have got options here for both. They're going to set the LED pin as 0. Obviously here this has been done, you're going to be using the CS, which is used for the SPI to set the SDI pin. Now, the first things we would need to do is we're not going to use SPI, so we would have to comment that out and uncomment this one. However, if you then try to compile this, it won't work. And this threw me for a little while, because when you look at it, you think, oh, this is great. But there was an issue, and it got me. And it took me a little while to find out what the issue was. And all it was, in here, you needed to state what the I2 address was for the I2C. So in my case, it's OX27. With that in there, this now would work. And basically, the nice part about this module is you've got the same down here, which is similar to what we had on the PCF. Here you've got the MCP.digital write, or we can use the read as well. So that basically is what we've got there. Now the only difference between this one and this one here, as I say, this has been adapted to run on the ESP32. So here I define which pins I'm using for the SDA and SCL. Obviously here in the wire begin, because we're modifying it, we have to tell it two parameters, which is these items up here. And then in the MCP.begin, we quote the address of the I2C, in this case OX27, but we also include the wire. This little bit here is a for loop. I put this in because I've been playing around a little bit, and sometimes, obviously, if you've set a pin high or as something else before, this just makes sure all 16 pins are set as outputs, and I've used the digital write pin, so that's all pins as it's going through the for loop to low. So that just makes sure everything is turned off low. We've got the serial begin, and we're using it in this case as 115-200, and all it's going to print out is telling you that the MCP23017 has been initialized for the ESP32. Then here what I've done is I'm basically setting this, so it says here blinking every 100 milliseconds. I've actually changed it, but so in this case here, I've told it to blink pin 3. So in this case, that would be known as PA02. I want it to go high, delay it for 50 milliseconds, then set it low, and that's it. So it's just a a simple example that you saw me showing earlier. Obviously, maybe later on in the next series, I will look at showing you how we can use it for inputs. But I just wanted to keep this simple to show you what we can do using this device. And as I say, you will be seeing this on future demo planks when I get round to demoing the LCC.